Okay, let's look at this example for conditional probabilities. Again, suppose we have two identical jars, 1 and 2. Jar 1 contains 4 red and 3 blue balls. Jar 2 contains different combination of balls, red and blue balls, 5 and 1. So we select a jar at random and then select one ball from this jar. A typical question we might ask about this process is, what is the probability that the ball drawn is blue? The analysis can be simplified by considering the tree diagram in figure 2a. So let's look at... Okay, so here we have figure 2a. So again, we just have a starting point, and we go to jar 1. I'm sorry, we go to stage 1, and there's two possibilities. We choose one of these jars. And then once we chose jar 1 for example, we say there are two possibilities for stage 2, red and blue. Same thing for jar 2. Okay, now here we write along the edge of the tree diagram, or I guess we should say one of the branches, but edge is good. We write along one of the edges the probability of jar 1 and the probability of jar 2. So that's a half and a half. And then here we go to the next set of edges. So this edge. So what should we write here? So we're going to put probabilities on these edges, but the probability that we're going to put is, since we're already on the path of jar 1, this is the probability of red given that we're on jar 1. That's the way we're going to do this. And this is the probability of blue given that we're on jar 1, and this is probability of red given that we're at jar 2, and so on. So what was the probability of red given that we were in jar 1? We have to go back and look at the, if you don't remember, which I don't, 4 red and 3 blue are in. So the probability of red is what? 4/7 given that we're jar 1. So 4/7. Okay, and the other ones we fill out the same way. Okay, now we have this now we've done this level. Okay, now let's go back to the question. So what is the question? What is the probability that the ball drawn is blue? So in terms of that tree, we get blue here, and we get blue here. So there's two ways that we can get blue. One is by following this path, and one is by following this path. And these two paths are mutually exclusive. And anyway, we can, so the probability of blue is the probability of going on this path plus the probability of going blue this path. So let's see that. So we want to find the probability. Okay, now they just wrote the probabilities. They didn't write the notation of it all like they had before. But anyway, it was a half and 4/7, a half and 3/7, and so on. So the probability of getting blue this way is this times this, because this is this is the probability of jar 1 and blue. So the and, remember, is intersection, and intersection is the probability of B times the probability of A given B. So that's the probability of blue that's the probability of jar 1. Sorry, I made a mistake. So the probability of jar 1 and blue is the probability of jar 1 times the probability of blue given jar 1. That's just that rule that we just looked at. So jar 1 is a half, and blue given jar 1 is 3/7. So we get this. So we get that. And the other way, same idea. It's the probability of jar 2 times the probability of blue times the probability of jar 2 times the probability of blue given jar 2. Now you might ask, we could have also written this like this. This could have been probability of blue here, and this could have been the probability of blue here, and this would have been jar 2. But then you would have had jar 2 given blue. But that's very hard to even think about it. So that we don't want to do it that way. But because given blue, that's not actually the direction that the graph follows, so to speak. So we want given jar 2, what's the probability of blue? That we can think about. So you could do it the other way, but then trying to figure out what you have here would be very hard. But this one, trying to figure out what this is not hard at all. Probably, given that it's jar 2, what's the probability of blue? That's very easy. It's just 1/6. Okay, so you could do it the other way, but you'd get stuck trying to figure out what this term was. So let's read what they say here. Read "and" along the branches of figure 4b. So what they mean is if you're going along a branch like this, A, then B, then this is the probability of A and B. Next one, read "or" for mutually exclusive paths. So that's what I was saying before. The paths were mutually exclusive. So we have "or." So it becomes plus because it's mutually exclusive. And if the probability of B given A equals 0, then the branch from A to B is omitted, which they do here. Here's the first one, and the second one, and the third one, and the fourth way. Okay, so they get this number. Okay, I'm not going to go through this example, but you can read it here and the solution there.